Hello. So in this video we will see the large signal analysis of the 5 transistor OTA. So basically what will happen if the input voltage is swinged from lower rail to a higher rail, or very low voltage to high voltage, and how the characteristics will look like. Okay, so if you see here, simply this is my circuit. Okay, this is my complete circuit, and this is my Vin1 and this is my Vin2 and this is my Vout from this node. Simply, let's say if this is very high and this is very low, what will happen? Simply this will be the off, this will be on, this will be on, and this will be on, but I will be 0. So this VDS will be 0, and thus this output voltage will be VDD. So this is the voltage. Okay, now let's go and see what will happen if Vin2 is very high. Okay, let's say Vin2 is very high. What will happen? So in that case, if this voltage is very high, if this voltage is very low, this is off because VGS will be 0, less than VT. No current. This is VDS, no current. For that VGS is 0. This is VGS 0, I equal to 0. Okay. So there is no path to current flow. Okay. Since it is on, this voltage is very high. Okay. So this MOS is on, but there is no path for the current to flow through this branch. Okay. So what will happen? This VDS is 0, and here also there is no path for this to current flow. Here also no current path. Here, there also VDS is 0. So both VDS, this VDS1, VDS M2 and VDS M5, both are 0, hence Vout is 0. So this voltage is 0. Okay, and in between, at the common mode voltage, when Vin1 and Vin2 are same, then we have some common mode voltage at the output. Okay, and the characteristics will look like something like this. Okay, now let's go and see what will happen if if the input is slightly greater than the above common mode. So what will happen in that case? So what does it mean? I'll chase the reason, this one. Okay, when Vin1 minus Vin2 is positive, in that case what will happen? Simply this current, since this voltage is increased, okay, so what will happen? The current will increase, this voltage will go down. Okay, why this voltage will go down? Because this VGS has to go low for current to increase in this branch. So that is why this voltage will go down. Now since voltage will go down, here also VGS will increase more. This VG has to decrease. Basically VGS has to increase for more current, so thus VG will decrease, and here also current will increase. Okay, so first current will increase, and here the voltage is decreased Vn2, so current here will decrease, and thus the total voltage, let's say some cap is there, so total voltage is 1 minus 2. Basically the current from the top will charge the cap, and current from M2 is decreased, so it also again help in charging the current, so Vout will increase. Okay, so basic thing is this. Now let's go. So in this case Vout is increased. Okay, and what will happen if Vin1 is less than Vin2? In that case, let's see what will happen. Okay, now when this is increased and this is slightly decreased, So current will decrease here, this voltage will increase, this current will decrease, this current will decrease, and this current will increase. Okay, so what will happen? The current through this cap will go down, so the voltage V out will go down. Okay, so this is the basic analysis of the uh, the characteristics of the 5 transistor OTA. Now let's see the region of operations and all that, whatever it is there. So whatever I have mentioned, I have just mentioned here in this notes, if you can see closely. Okay, so simply let's go here. When Vin is very high, I already mentioned that when Vin is very high, M2 is off. Okay, just see there, and since M2 is off, there is no path to current flow, and M4 is on, so therefore VDS is 0 and VDD is output is VDD. Note that M1 is linear. Why? Because Vin is very high, so M1 will be in a linear. M3 always in saturation. M4 deep triode, because no current is flowing through this, not able to flow any current here, so that is why deep triode, because on. And M5, M2 is off, M5 will be in a what? Saturation, because there is a current through this branch, so it will be in a saturation, and we have enough voltage available. Okay, now let's see when Vin is very low. Simply I mentioned, if this is if this is low, M1 is off, no current through this. Okay, so I already mentioned M1, M2, M1, M3, M4 off, Vin is very high, and IM2, since there is no path for current to flow, so that is why this branch has no current, but it is on, therefore VDS is 0 for M2, M5 and M2, and therefore output is 0. So from here you can see that M1 is off, 3 is off, M4 is off, M2 and M5 are in deep triode. Simple. Now when Vin is increased, let's say this region, this is the region, in that case I already mentioned that from here to here, if you see the region of operation, compare it, M1, M3, M4 all are off, M2, M5 are deep triode. Here M1 is, what is the state of M1? M1 is linear, so off to linear. Then you can see all the region of operations. Now let's go to the when Vin is increased slowly from lower, very low voltage. So if you see here, then okay, so where I was, sorry for interruption. So here if you see here, then Vin is increased. Okay, so Vin is increased, sorry for the interruption. Now let's the current will increase in this branch. So what will happen? This current will increase, this current will increase, and this potential will increase, this voltage is increasing, so obviously this will go in saturation. Okay, M2 will go in saturation. So M2 will go in saturation, because earlier it was VDD, earlier it was 0, so 0 to V out, so it is increasing, so that is why M2 is in saturation. So M1 is in saturation, because VF, because of current increase, this voltage is going from what was the earlier voltage here. When Vin is very low, there is no current here, this voltage was VDD, so still it is in the saturation. Okay, and this is also in saturation. This will be, what is the state? Because earlier VDD, deep triode, so now it is going from deep triode to saturation. Okay, M4 is going from deep triode to saturation when you are increasing the current voltage V in from very low to high. Okay. Similarly, M2 is going into saturation. M5, simply M5 is going in, M5 is in saturation from deep triode to saturation. Why? Because this voltage is increasing. So in between somewhere it will reach to the saturation. Okay, and that reason is this. Okay, now when V in is increased, then this voltage is increasing V out. So this voltage VDS is what will happen? It will go in a linear region. Okay, so when this linear region, you have to understand that how it is going in a linear region. Basically, if this voltage is increased, current will increase, more and more current, and this voltage is increasing, so VDS of M4 is decreased. So that is why it is going into the triode region. So this is the basic operation of the last signal analysis of the 5 transistor OTA. Now just few things to understand here, I'll show you, is that in the common mode signal, when this are same, everything has to be in saturation. So that is why if you see here, V out should be greater than V in Cm, means input common mode voltage, and minus Vt should be greater than the whatever V out at the when common mode voltage is there, it should be greater than V out should be greater than input common mode minus of threshold voltage to remain in a saturation in the center. Okay, so that common mode voltage we have to decide that what should we have to take. Okay, and if let's say if this is increased, okay, what used to happen? If this voltage if is high, let's say, then this voltage has to go high for saturation region. Okay, but problem is if it goes very high, this will go in a linear. So that is this case, that when common mode voltage is increased high, we have to take care that this voltage should be, the VDS of this M4 should be greater than the what? This VDS4 should be greater than the saturated VDS min, that is the VD sat of the M4. For that case, you see, V out max should be greater than the V in common mode voltage minus threshold. What is this condition? V out max is this VDD minus VD sat M4, and from here you will get the equation. So basic concept is, when you increase this voltage will, when you increase this voltage will increase, and because of this will go in a linear. So we have to make one constraint here, that how much we can increase the common mode voltage. Similarly, when you decrease this, so what will happen? If you decrease this voltage will decrease, so this M5 will go in a linear. Okay, so we have to make constraint how much we can decrease the common mode voltage. So here also, if you see that VDS5 should be greater than the VDS sat of M5. From there you get the equation. So this is a simple analysis with respect to the common mode voltage, that we need to be minimum and maximum range we are required to make the all transistor in the, to remain all the, to make it all transistor to remain in the saturation. Okay, one most important thing is this, that when this voltage Vin1 and Vin2 are same. Okay, when both these two voltages are same, then these two are also same. Basically, V out is equal to Vf. Okay, this we have to prove. So for this, what my constraint is, what I have to prove is that V out and Vf are same when V in, both V in are same. So let's say that this voltage is increased, that is Vf is greater than V out. Okay, this voltage is greater than this. So this voltage, what is this voltage? VDD minus Vf is less, and since V out is less, this voltage is more. So what does it mean? Because of channel length modulation effect, if you visit the previous videos in the basics of MOSFET, when VDS difference if you see, then because of that higher VDS will have the higher current. So hence this M4, IM4 is greater than IM3. This is first point. Now second thing is, if you see here, since this voltage is higher, this VDS is higher, IM1 is higher. If IM1 is higher and IM1 and IM3 is same, IM3 is greater than the IM4. Okay, so here if you see here, IM4 is greater than IM3 is greater than the IM4. So hence both are contradicting to each other. Thus it is required to have Vf should be equal to the V out. V out should be equal to Vf. Okay, so by this you can say that when this potential is same as this potential, V out is also same as Vf, and that is equal to, because of the current mirror conditions. Okay, current mirror obligation, because of the current mirror obligation, these two voltages are same. Okay, so that's it for this large signal analysis of the 5 transistor